Good morning. I hope everyone's doing well. I know this is not Mr. Watson. This is Mr. Slater. I'll be going through the do nows for this week. First thing is for these do nows, remember, we are starting a new unit on genetics 2. Okay. This time, we're not only looking at how genes get transferred, but how we can predict these transferring of genes. The first question on Tuesday's do now, it says the allele for black fur is capital B. The allele for brown fur is lowercase b. So black fur is the dominant trait. Brown fur is the recessive trait. It says what kind of parent genotypes would produce both black and brown fur individuals? Well, let's think. If we need to produce both black and brown fur individuals, we need that genetic information to carry from the parents. So most likely, both of the genes or both of the alleles have to be present in the parent genotypes. And the only genotype we have that allows us to have both the dominant and recessive is heterozygous. Remember, heterozygous in this scenario would be capital B, lowercase b. All heterozygous is, it means that it has both the dominant and recessive trait coming together. For Wednesday's do now, it tells us to create a Punnett square for a cross between two heterozygous genotypes. Well, according to our last do now on Tuesday, we know heterozygous is capital B, lowercase b. Well, let's do this in our other scenario, okay? Remember, again, heterozygous means you have one dominant allele, one recessive allele coming together. So here's our example. We've seen these before. What we'll need to do is drag the appropriate alleles to create the appropriate parent genotypes. So for the first one, we would want to drag our capital E, and then because it's a heterozygous genotype, we would drag a lowercase e allele, or a dominant and recessive allele would come together. So that's our first parent. We need to make our second. Our second is another heterozygous. We would drag the capital E and the lowercase e, or the dominant and recessive alleles. Now we would just want to cross our Punnett square. Well, we have a dominant and dominant allele coming together, so that would make homozygous dominant. For this one, we have a dominant and recessive allele coming together, which would create a heterozygous. For this, we have a dominant and recessive coming together. So again, we would make a heterozygous. And lastly, we have a recessive and recessive allele coming together. So we would create homozygous recessive. So that's how we would complete the Punnett square for this activity. Remember, in genetics 2, we're trying to figure out how we can predict what is going to happen. For Thursday's do now, this time we're looking at pedigree diagrams. Again, we've looked at these before in the past, but we need to dive a little more in depth of how we can predict the genetic makeup. For this question, it says, what are the two different genotypes individual 1 could be? And justify your answer. So we need to look at individual 1, which is at the top. Individual 1 is a square that's not filled in. Before we make any statement, we need to read the key to understand what's going on. It tells us that capital E allele is for free earlobes, meaning our earlobes, there's two different types. There's ones that have free flowing earlobes, and other people have actually attached earlobes. Well, the dominant trait's free earlobes, the recessive is attached. If we look at individual 1, we'll notice that the non-filled in square means that male with free earlobes, meaning this individual is a male that is representing the dominant trait. If that's the case, what two different genotypes allow us to express the dominant trait? Well, let's think. We have 3 different types of genotypes. We have homozygous recessive, meaning only recessive alleles are present. We have heterozygous, meaning we have a dominant and recessive allele present. And we have homozygous dominant, where 2 dominant alleles come together. Let's find out which one would make the most sense. If this individual is expressing the dominant trait, well, the dominant allele has to be present. So the only 2 alleles that could make sense in this situation, or two genotypes would be capital E, and capital E, lowercase e. For our last do now for the week, what we're looking at here is the same pedigree diagram, but a different individual. This time, we're looking at individual 2, which is at the bottom. We know the dominant and recessive alleles, but we also need to understand what this individual is. And let's use the key again for this. If we look, it's a shaded in circle. So if we go to the key and look down, we find that the shaded in circle is a female with attached earlobes. It says the question, according to the chart, what could be the genotype of individual 2? Well, if it's expressing the recessive trait, there's no way that a dominant allele can be shown, or that would take over. So the only genotype individual 2 could be is lowercase e, or homozygous recessive. All right, the last two things that I want to do is our Throwback Thursday question. This is a convection current, okay? The main thing that we need to understand about convection currents is this. When we have less dense material, it's going to want to rise. If we have more dense material, it's going to want to fall. 3 and 1, the locations of them, this is where the heating or the cooling occurs. Think of a lava lamp. The heating happens at the light bulb at the bottom. Well, Earth is similar. Our heating occurs at the inside of Earth's core. So when material comes down here, it begins to heat up, becomes less dense and travels up. Once it gets to 1, it cools off. And then eventually it becomes more dense and falls down. And the last question we have here is how we can think of gravitational forces between two objects. This was when we talked about force in motion. It says, place one object on the dashed line so that the gravitational force between the object is guaranteed to be greater than x. B says, place one object on the dashed line so that the gravitational force between the objects is guaranteed to be less than x. Okay, it says there are maybe more than one correct answer. You may use each object more than once. So let's see. Let's place one object on this dashed line here. That would allow the gravitational force between the objects to be greater than x. Well, what I would do is we need something with larger mass and a closer distance. So why don't we use the most mass possible and allow for it to be closer than the other? Because when two objects are closer, their gravitational force levels are more, but also if their mass is greater, their gravitational forces are going to be more as well. So we increase both. For B, it says us to place one that's less than. Well, let's go to the extreme. Let's allow something to be the least amount of mass possible in the farthest distance away. Because it's far away, our gravitational force is less. And also because it's less mass, the gravitational force will be less as well. All right, I hope this helped for the do nows. And again, I hope you guys have a great week and see you all later.